On number 76, we need to factor to find the zeros. First thing we always look for in factoring is a GCF. There is a GCF of x that I can factor out of everything. The x squared minus 12x plus 36 factors, and it's actually a perfect square. If I ask myself what multiplies to 36 and adds to negative 12, that's negative 6 twice over. So my zeros, what makes it 0? Well, I look at each factor. 0 would make that 0. 6 would make the x minus 6 0. 0, well, the factor of x really is raised to the first power. So this solution has a multiplicity of 1, which means graphically I'm going to cross through the x-axis there. I'm going to slice through it. The 6, now I don't look at the number 6, I look at its multiplicity. Its multiplicity is 2, so it has a multiplicity of 2. More importantly, that's an even multiplicity, which means I'm going to bounce off the x-axis. So to get a general idea of what this graph looks like, I know it's going to hit at 0 and at 6. I'm going to hit the x-axis at 0 and 6, and those are the only places I can hit. Looking at the original function, it was an x cubed, and it's positive. That means that its end behavior is going to be falling to the left and rising to the right. So I have to start down low at 0. Since it had an odd multiplicity, I'm going to cross through. 6 had an even multiplicity, so I'm going to bounce off. And I can see that I do end up high and start down low, just like I was supposed to. On number 77, now we're reverse engineering a polynomial. It has to have degree 3 though, and these are the only zeros. So if 0 is a 0, that means the factor would just be an x. If negative 4 is a 0, that means the factor must have been x plus 4. Again, I'm doing everything in reverse. Now, here's the issue with this. If I multiply this together, it would only have degree 2. What this means is that somebody has to have a multiplicity of 2 on them. Now, technically, it can go on the x or the x plus 4. The easiest place would be to put it on the x. That still doesn't change that 0 is a 0, but it doubles its multiplicity. If I then multiply this out, that would give me x cubed plus 4x squared. There's a possible answer. Another way I could have done this would have been a harder way, but I could have squared the x plus 4 factor. That would have made this a little more difficult, but I still could have done it. So I still have the x factor, the x plus 4 squared. If I FOIL that out, I would have had that, and then I would have had to multiply the x through all that. Give me x cubed plus 8x squared plus 16x. So technically, both of these are correct. Obviously, this first one would have been simpler. On number 78, we're just asked to divide. Since I'm dividing by a linear divisor, I'm going to use synthetic division. So if I'm dividing by x plus 3, remember synthetically, that means it's going to be a negative 3 that I divide by. Note that my dividend does not decrease in powers by 1. 4, then 2, 1, and none. That means I'm going to need a placeholder. So the coefficient in front of x to the 4th is 1. There is no x cubed, so that's going to be a 0. Negative 10 for the x squared, negative 2, 4. So I'm going to roll through this. Remember, I always drop down the first number, and then I multiply the divisor by the number. So that's going to be negative 3. Then I add. And I just keep the process going. So this will be 9. Then I add 3. Add those together. Negative 3. Add those together. I had a degree 4. When I divide it, it's going to drop by 1 degree. So this is going to be 1x cubed minus 3x squared minus 1x plus 1. Remember, this last number is my remainder. That's going to be plus 1 over my divisor, x plus 3. For number 79, we're using synthetic division again, and we're using it in conjunction with the idea of the remainder theorem, which says that if we divide whatever our remainder is, that's equivalent to if I had plugged negative 2 in. So basically it's saying, hey, if you would plug negative 2 in for every x, what would you get? But it wants us to show that we would get it with synthetic division. So f of negative 2, that means negative 2 is what I'm going to divide into. I do not need a placeholder on this problem. Whatever I get for a remainder, that's going to be what I care about here. So again, I multiply and add. I multiply and add. I multiply and add. And that's going to give me negative 37. That is my answer on this one. That is what f of negative 2 would equal. For number 80, I am showing that negative 3 is a solution to this. That should mean that when I divide by negative 3, I get a remainder of 0. This goes with that remainder theorem. I will need a placeholder on this one, so it's going to be 1, negative 19. Oh, no, sorry. That's where I need the placeholder. There is no x squared term, so I need a 0 there. Negative 19, negative 30. I should be getting a remainder of 0, hopefully. So as I work through this, yes, I do get a remainder of 0. That's good. This now also wants me to find the other solutions. I've just taken this from an x cubed down to an x squared. So this is 1x squared minus 3x minus 10. That factors. The numbers would be negative 5 and positive 2, which means my other solutions are 5 and negative 2. So technically there were 3 answers, 5, negative 2, and the negative 3 that they gave me. For number 81, this one's kind of worded strangely, but it's essentially wanting me to do division. So it wants me to write f of x in this form. This q of x part, that is the quotient. So it wants me to divide. R is the remainder. So my k value is negative 2. So I'm going to divide by negative 2 synthetically. This problem does not need any placeholders. And as I work through it, I end up breaking this down to x squared minus 7x plus 3, and there's a remainder of 2. Now, I'm not going to write that as a fraction, just the way this problem wants this written out. So the x squared minus 7x plus 3, that is the quotient. That's the q of x. So that's going to go in for q of x. -2 is going to go in for k, but realize that it's x minus -2. So to write this function in the form that they want, the x minus k is going to be x plus 2. The quotient was the x squared minus 7x plus 3. The remainder was 2. So I'm just going to say plus 2. And this is a way to write f of x. Now, what this actually means is if I were to multiply the red times the blue, multiply all that together, do all the foiling and all that fun stuff, and then tack on the 2 at the very end, I actually would get back to my original f of x function.